This is day 7 of Advent of Code 2025, and this challenge is called Laboratories. Thank the cephalopods for the help and exit the trash compactor, finding yourself in the familiar halls of a North Pole research wing. Based on the large sign that says Teleport Hub, they seem to be researching teleportation. Can't help but try to find yourself and step onto the large yellow teleporter pad. Suddenly, you find yourself in an unfamiliar room. The room has no doors. The only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Since this is a teleporter lab, there are lots of spare parts, manuals, and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays error code OH-NO, which apparently means that there's an issue with one of the tachyon manifolds. Quickly locate the diagram of the tachyon manifold, the puzzle input. The tachyon beam enters the manifold at the location marked S. Tachyon beams always move downward. Tachyon beams pass freely through empty spaces, the dots. However, if a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam continues from the immediate left and from the immediate right of the splitter. So if we have this, it would go down to here. The next one would go into that, but it would stop and split to the next one. And it would carry on as so, go down the split, split, and it would keep doing that until reach the very end. To repair this teleporter, you first need to understand the beam splitting properties of the tachyon manifold. In this example, a tachyon beam is split a total of 21 times. Analyze your manifold diagram. How many times will the beam be split? Okay, interesting. Curious to see about the actual input for this. And okay, it's very large. I assume there'll be some of these which don't actually split into anything, or it's... yeah, so if this split it here, it would go down here, but this one wouldn't be reached. Okay, that makes sense, so we will get started on that. But we'll first grab this, put it into here. So we'll do int total splits is equal to 0, and we will put that here. We will record int start row is -1, int start col is equal to -2. Actually, -1 doesn't make sense to make -2. We'll go through each row inside of the input. R is less than input. Actually, since we're working with the row, we'll get, and we'll probably be using this throughout. We'll grab the height is equal to input.count. Oh, don't know how I ended up typing that twice. But int width is equal to input, then first index dot count. No, this should be length. So starting that, r is less than the height, r plus plus, and we will just, since each row is a string, we'll see if we can grab the index of it from that. So we'll do int c for column is equal to input r dot index of s. Then we do if c does not equal -1, as that's the default value. We'll do start row is equal to r, start col is equal to c, and we would break from it. Okay, so we've got our initial setup. So we now know where we are within it. So when we look at it as this, we start on a row, and so there's nothing, 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 nothing. When we get to here, there is the beam, nothing, nothing, nothing. It would go down, there'll be no beams up to here, get to here, and it would turn this into a beam. Okay, so what we could do, so I guess something that you might think of doing is recording like all the coordinates of the beams, but instead you just need to know what row you're on and then what the location of the beams are. So we know it's in this location. So if we go to the next row, we know it goes down, so it's going to stay in that location. And then it's a matter of, okay, we go to this one, it's still in the location, but now there's a splitter here. So this beam is no longer in this column, it's in this one and this one. And when we go down, we know it's still going to be there. So we could actually record these beams as booleans representing the column it's in. So we'll do a bool array called beams, and we will set this to a new bool which has the width of it. So the width being the columns, and what we then can do with beams, we set starting column as true. So what we do now is we know what column. We know where the beam is. We need to go to that beam. So we'll do 4, and then we're just basically iterating through the remaining columns. So it could be that S starts here. Actually, where does it start? Okay, it's always at the top. Okay. What we'll do is int row is equal to start column, but we'll do +1 as we're now trying to figure out where it goes on the row below it. So we've got that r less than height r plus plus. So we will grab the row, which is input r, and now we need to go through each column. So for int c is equal to 0, c is less than width c plus plus. Now, if there is no beam, so that would return true. If there's no beam, we just continue because there's nothing to process. Okay, so this is beams. This is the, so we're currently processing the row that's below the beam. So this is, beams is the row above. So what we now want to know is what cell is this beam going into? So we'll do a character of cell is equal to row C. And what we'll do is if cell is equal to caret symbol. Oh, okay, let's just, is it possible for there to be a beam in the very, okay, so there's no possibility where it's in like the very edge. So we don't need to account for that. But if cell is equal to this, then do beams C -1. Actually, no, we need to create a new Boolean array because there's still consequence beams we need to calculate. Where we just grab this and create a new one here. This is next beams. Next beams is equal to true. Next beams +1 is equal to true. And that should be all that we need to do for that, because we haven't recorded the row above it. We haven't gone down to here and said, yep, that is it. So it's defaulted to false. So this is if cell is equal to this. And if it's not, we do an else. And then we just do next beams C is equal to true. So from here, so the number was 21 splits. A beam is split 21 times. Is there anywhere where a beam overlaps with each other? Here it would. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. So we should go back to here and total splits ++. Okay, let's run this and see if that worked. Okay, you only got 1. Oh, okay, I forgot to do this. So beams is equal to next beams. Forgot to actually change that. So let's try again. Still only 1. Doing total splits, did that. Okay, we'll do a console.writeLine here and see what this all looks like. So it starts 7, 8, 7, 9. Doesn't seem to be working as expected. Wait, it's on row 8. Start column. Yeah, let's add something here. Console.log. Console.writeLine. Found S C C R R. Actually, we should do start row, start column. Okay, so I've got that. Now let's print the row here. Row. Okay, something's definitely gone wrong with this. Oh, I did column instead of start row. Let's try again. Okay, I gave 21. Let's remove these console write lines and put the actual input in. And now let's run it. We got 1649, and that was the correct answer. So now let's go on to part 2. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you're surprised to discover that it isn't a classical tachyon manifold, it's a quantum tachyon manifold. With a quantum tachyon manifold, only a single tachyon particle is sent right through the manifold. The tachyon particle takes both the left and right path of each splitter encountered. Since this is impossible, the manual recommends the many worlds interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and in the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold. In the above example, there are many timelines. For instance, there's a time where the particle always went left, there's a timeline where the particle alternated, or there's a timeline where the particle ends up at the same point as the alternating timeline. It takes a different path to get there. In this example, in total, the particle ends up on 40 different timelines. Applying the many worlds interpretation quantum tachyon splitting to your manifold diagram, how many different timelines would a single tachyon particle end up? Okay, interesting. This sounds like we need to turn this into a recursive function, something. Okay, so after thinking a bit more about this, instead of using balloons for the beams, we can instead use integers or not just numbers. Start off with, switch back to the original. Start off with the number 1 here, and it's 1. Then this happens, and this will be 1, 1. It comes down to here, 1, 1, 2, 1, and so on until it reaches the end. So you're recording all possible combinations, or I guess ways that has gone through the paths. So I think that is how you would do it. Okay, so we'll copy all this and put that here. We will change beams to how many? Oh, just make it long, just in case. I don't think it'll get that much, but we'll do that. And then we set this one to 1. So for the next beams, we change this to this. And now what we do is if this is equal to 0, we ignore it. But now we do this plus equals the number. And if this is the case, then we just do equals here. Actually, no, this needs to be plus equals in cases split somewhere. So we do that, and then don't need this initialized at the top, but we will initialize it. Yeah, we don't need you at all anymore. So we will right here do this. Then we'll do for our beam count in beams. We can just do for each, and this plus equals beam count, and change that to long, and we print it out here. So I think that's all that needs to be done for this part 2. Okay, we've got 40. Okay, yeah, that's correct. Okay, we'll switch back to our actual input. We run it again, and we got that very long number, so it's a good idea we changed it for long. We submit it, and we got the right answer. If you like this video, make sure to like and subscribe.